This course is electrical machine design and is useful for 5th semester student. I am going to discuss about your unit second. The content of the unit is like this. In this unit, we will study about the different types of transformer design. Means in this part we will study output equations of the transformer for single phase and for three phase. We will study here for single phase and three phase. Both we will study for single phase and three phase. Main dimensions. Main dimension we will study here also. kVA output for single phase and three phase transformer we are going to study here, and window space factor we will also study in this unit. Window space factor, overall dimension, how can you calculate the overall dimension based on your voltage current ratings. Based on your voltage and current rating, our overall dimension of the transformer will be calculated. Operating characteristic, then we will see how what are the operating criteria and operating characteristic of the transformer, and voltage regulation also we will see, and how the dimension of the transformer is designed so that the regulation and output power of the output power should be maximum available. So a designing factor will be there that will decide our transformer how much it should be giving output power and how much load should be connected so that the transformer should work satisfactorily. Then we will study about the no load current. This no load current you have also studied the importance of no load current. This is denoted by I naught, no load current, and its effect is that suppose a transformer like this, which you have studied in your previous semester in the case of the transformer, that this is your primary winding and this side is your secondary winding. So secondary is open, still the primary is giving current, primary is supplying current, and this current is known as no load current of the transformer, and it has a very big role because this no load current is being utilized to magnetize the core of the transformer. Most of the part of this part goes to magnetize the core of transformer. Means about this has two parts. One part is magnetizing component and another part is iron loss component. This part is very big value, means 95 to 98% of I naught, no load current, means 95 to 98% of this no load current is going into the magnetizing part, and remaining 2 to 5% goes for iron loss. This circuit also you have seen during the no load test of a transformer. I will also here recall you, this part was II, this is denoted by RI, and this was XM, and it is denoted here current flowing is IM, and this II, and here the current coming is I naught. So most of the current is going in the form of IM, that is called no load current. The logic is that this no load current is utilized as to magnetize the core of the transformer. If this core is not magnetized, the transformer will not work, because the medium between this side to this side is this core, and core must be magnetized to transfer the energy from primary side to secondary side. So this core has to be magnetized, and this core material must be a good magnetic material, so that the most of the flux coming from this side goes into the core of the transformer, and output voltage is obtained here. At this condition, it is open circuit, secondary side is open, still primary has some current to come, and if you increase the loading effect, load current in secondary side, suppose if you increase the load current in secondary side, still the value of I naught remains same, it does not change, remains same. Means if you increase the loading current, this I naught does not change. What change? Change primary current, I1. I1 is I2 dash plus I naught. This I2 dash you have studied in transformer. This is the secondary current referred to primary side. This is I2 dash is the secondary current. Means if you connect load here, and whatever current is flowing here, its effect, what is the effect of this current that will be flowing from the primary side is denoted by I2 dash. So basically, when this side, secondary side is loaded, like I am drawing here another diagram so that you can recall your previous concept. Some portion I am repeating here again. Suppose this is your primary side and this is your secondary side. Once load is connected here, so I2 will start to flow here, and now the current I1 from primary side will be equal to I2 dash plus I naught. If this current is 0, this will be 0 and I1 will be I naught. So this I2 is secondary current and I2 dash is the secondary current referred to the primary side. The formula you also know that this is the relation between I2 divided by I1 equal to N1 divided by N2. This relation, from this relation you can find the value of this I1 value, if you can find. So using this relation, I2 dash is obtained. I2 dash means, what is I2 dash? If you see from this relation, from here I am writing here. So I2 multiplied by N2 divided by N1 equal to I1. This I1 goes this side and this N2 come here and N1 here. So this whole thing is called I2 dash equal to I1. Means this current is the secondary current referred to primary side, which is equal to I2 multiplied by N2 by N1, or this N2 by N1 is also called I2. N2 by N1 is called 1 by A. This is called A. A is called term ratio, where A equal to term ratio is N1 by N2. This is called term ratio. So this something I have revised your concept. So this I2 is the secondary current and I2 dash is the secondary current referred to primary side. Keep in mind, once this current is 0, then I1 will be equal to I naught, means no load current. So another parameter we have to consider, that is temperature rise in the transformer. When load current increases, this I2 current increases, then temperature rise in transformer also increases. So we have also to design the transformer core or transformer winding and its insulation, so that once current goes high, the temperature should be managed in such a way it should not break the insulation of the transformer. So for that we have to design the tank of the transformer, method of cooling of the transformer. Also we have needed the method of cooling of transformer, so that when temperature increases, the oil in the tank, what happens, it goes sprayed, and when sprayed goes, so at this time the area, it goes high area, and due to high area its temperature goes down. So this thing we have to study in this unit 2. Now you see here the transformer, some of the characteristic I am again going to explain you. this character load on the transformer will be near the full load. Transformer, basically you have studied there are two types of transformer. One is power transformer, another is distribution transformer. Distribution transformer. So these two transformer we have to, in broad way we are classifying this transformer in two types, distribution transformer and power transformer. So for this power transformer, what is going to happen? Power transformer, this load on the transformer will be or near the full load. This transformer is applied at the site of generation where electrical energy is generated. So here suppose your generator is there and this is connected with the transformer. This is called power transformer. So this transformer is, every time this transformer is loaded, so it is working on the full load side of the transformer. So full load means this transformer has to the capacity to withstand the full load effect, and 24/7 this transformer is operating at full load. So full load throughout the period of the operation. When the load is less, the transformer which is in parallel with other transformer may be put out of the service. Sometimes may be happen like some transformers are in parallel also, parallel to this transformer may be here and another transformer operating, another transformer that is operating like this in parallel. These two transformers are operating in parallel. So generation 1 and generation 2. So what happened? Sometimes if load is less, so directly we are removing this transformer, disconnecting, but full load all the time this transformer is operating at full load. So its designing is in such a way that its efficiency should be maximum at full load for power transformer. This is efficiency. Generally designed to achieve maximum efficiency occurs, generally designed maximum efficiency at near full load. Therefore, iron loss is made equal to the full load copper loss by using a higher value of flux density. So higher, this point is important, is made equal to the full load copper loss. You know efficiency is maximum when iron loss is equal to the copper loss. Iron loss is constant loss and copper loss is variable loss. When these two losses are equal, then the efficiency of the transformer is maximum, and it is obtained by using higher value of flux density. In other words, power transformer are generally designed for higher value of flux density. Higher value of flux density is needed for power transformer. Necessity for voltage regulation does not arise. Here voltage regulation necessity is not arise because all the time it is loaded at full load and there is a no drop, no question of voltage fluctuation. So there is a no need of voltage regulation for our transformer. I am talking, you keep in mind, I am talking only about the power transformer. The voltage variation is obtained by help of the tap changer provided generally or high voltage side. So suppose if you want to change the voltage, you need to provide a tap changer that will change the voltage. But here, due to the load, voltage fluctuation is not considerable. We are leaving it. Only if you want to change the voltage, tap changing is needed. Generally, power transformers are deliberately designed for high value of leakage reactance. Their leakage reactance will be high so that short circuit current effect of mechanical force and hence the damage is less. So this is the main criteria for the designing purpose of the power transformer. Next part I will discuss about the distribution transformer. There is a slight difference between power transformer and distribution transformer. Distribution transformer which you see at your street side, whatever transformer is placed there, that is a distribution transformer. This transformer, power transformer, is generally utilized, used at the side of the generation side. So this transformer, distribution transformer, because load on the distribution transformer is changing frequently,